the number problems. And myself and the authors, we'd recommend, regardless of the age, so if you've got even high school kids, if you're just starting out with number talks, to start with the dot formations. And it's a really nice way of getting the students used to the routine and used to the idea of actually having multiple ways of solving a problem. This visual is just a sort of illustration of how in a number talk you start with that individual think time. So you've sort of got your method, your answer, and then through that sharing you get to see different solutions, and then that sometimes can spark new ideas as well. But the students really love listening to each other and sharing their ideas. Now, a number talk string is a variation on a number talk, and rather than inviting lots of different strategies, they're designed to invite limited strategies in order to develop new ones. So in this instance, you've got these three number cards going from left to right, and you can see that first one there. It's a dice pattern. It's sort of nudging towards starting with that bigger number and counting on that kind of thing in the hope that that will come out in that discussion. And then it's moving on to some others that are less obvious, but also hoping to draw out or apply those strategies to less obvious problems. And you've got the same sort of thing with these written number problems. And how that might look on a whiteboard is you present the first problem and you collect a few different strategies. Then you present the second problem and you collect a few different strategies. And then again, with your third problem as well. And you can see there that the first strategy on the 8 plus 6 is actually 9 plus 5 is 14. They knew that from the previous problem. So that's the thinking that they've applied that problem there. So these problems are related, and they come from there's a whole bunch of them. I mean, you could probably find some online, but these books are full of them. They've got for across all different operations from the first year of school right up. I did just want to quickly touch on maths talk routines in general. So I'm not sure if you're familiar with notice and wonder, same but different, which one doesn't belong. There are lots of really fun and playful maths talks, how they're a bit different to number talks. So for example, you might have a photograph with things about notice, or a number or shape to notice, or you might call like a list of number problems. So all of these visuals here are featuring number, but the questions that we're asking are much more open. So what do you notice? What do you wonder? And it's an opportunity to notice patterns, to think about things that are happening in number. And these are really, really rich discussions that we don't have time to go into today, but they aren't number talks. And I think there's a bit of confusion around, let's run a number talk today and it's a maths talk involving number. And the reason that I'm just a little bit concerned about that is that I believe that number talks that we've been looking at are what can really build our power to build our reasoning, so that we can develop these really strong set of strategies and understanding of place value over time. That I think it's really important to be able to differentiate maths talks from other maths talks, open-ended ones, from number talks. So, what's the same, what's different? I had used this particular prompt to launch a counting collections task late last year. So, got the students to look at what's the same, what's different, because I wanted them to see the value of a 10 frame for helping to count. And then they went off and they were like, okay, well, we can use a 10 frame to count. Again, this is a visual prompt that we can have a discussion about and do some noticing, but the questions are different and you've got multiple correct answers. It's less focused. It's beneficial for other reasons to that. I mean, which one doesn't belong is a really, really fun one, where you argue the reason why each quadrant doesn't belong. So the students are actually going to be adding numbers in their head. They're going to be thinking about how, why that quadrant is different to the others. And there's an argument